Hello, welcome back. This is a tutorial on hypothesis testing. In some of the previous videos, we talked about z-test and t-test, one sample and two sample. Now we are going to look into paired sample, wherein if you have the same data set after two and you're comparing with two conditions. For example, right now we are going to compare scores of students before a training program and after a training program. So we are going to use stats scipy library, and in this case again, in all of the t-tests we compare mean, either it's one sample, two sample, or paired sample. We are comparing mean. So that's import numpy as well. I don't think we need numpy here, but let's anyway. So before training, we have, let's say, a score of 75, 80, 5, and after training. So what we are trying to do here is we are trying to see if there's a difference in the overall results before training and after training by using t-test to understand if there is a difference between the two samples after the two condition t-stat. So let's perform this. We are going to get the statistic value and the p-value, right? So, and we have to pass before and after training as two arguments here. Let's see what happens. 0.0, which means there is a significant difference. Let's try to copy the same and see how it works. Like this. I think we need to slightly make some difference. 74, 79, 64. So now you'll see that, yeah, again you're still able to see that there is a difference. So let's try to reduce the numbers by 59. I think since the sample size is so small that it shows there is a difference. So let's add some more values to this. 70, 85, 75, 65. And I'm gonna make a very small difference as in order to reach, accept the null hypothesis and say that there is no significant difference. Is what I'm trying to show you. 74. So I have taken two scenarios. So you can see here in this scenario, there's not much difference. You can see that like we have a 70 and here we have 71, 75, 73, 80, 87. So there's not much difference, and you can see that here you're getting, like one has the p-value and 0.0, and you have some numbers followed by some numbers, so it's rounded off to 0.0. So basically you're getting this sort of a value. If you consider that, then you're going to see that the null hypothesis will be accepted because there is no significant difference, right? And you can even here you can see that there is not much difference. Now let's take a case where after training the scores increase from 70 to 80, 75 to 85, 80 to 85, and so on. And now you'll see that there is a difference, and this t statistic is this particular value, and you're going to see there's a difference in, I mean, it's a very small number. You can see e to the power of minus 0.05, And now, when you try to check, you're going to get a null hypothesis to be rejected because there is a significant difference. So this is how basically this example tells you that if you have two scenarios, one scenario is before training and another scenario is after training for the same data. So the same people who have taken test, initially they had score before training, so and so, and after the training, here you can see there is a difference. People have got more marks. So when you try to apply a paired sample test, you're going to see that it is going to compare and tell you that yes, there is a significant difference, and that's why we are rejecting the null hypothesis. So that's pretty much it, and thank you, and see you soon in next videos.